In this video, I'm going to explain how to do a problem where you have to predict either the product of a reaction, as in number 1, the reagent in the reaction, which is like number 2, or the reactant, as in number 3. The first step of doing this type of problem is to recognize the type of reaction. This is easy because we only have one reaction type so far, and it is substitution. In this kind of substitution reaction, we have an alcohol which turns into some kind of alkyl halide. So that's step 2. That is recognizing the functional group transformation. So on the left, we should have all alcohols, and on the right, we should have alkyl halides. The other product in this reaction is always water. So we can just go ahead and draw that in for the missing product side of number 1 and 2. The other thing we need to do is balance the organic portion of the reaction. So that's going to help us. We need to make sure our carbons balance out. There's the same number of carbons on each side, the same number of halide ions, and the same number of hydrogen atoms. So in this case, I have my alcohol that needs to be replaced. It's being replaced with the bromine atom. So I will simply draw the molecule the way it looked exactly without the alcohol group and replace the OH with the Br. I have 6 carbons on the left, so 6 carbons on the right, bromine on the left, bromine on the right, oxygen on the left, oxygen on the right. And if you count the hydrogens, they should all match up as well. It's a little bit easier, I think, for this kind of reaction to write in the missing reagent, because looking at the products, it's pretty obvious that we have a chlorine that has to be part of the reagent, and the reagent is always some halo acid, so our acid is HCl. For the predicting the structure of the reagent or the reactant, alcohol, that might be a little trickier, but we just need to go backwards. We need to look at our halide and say, okay, well, that iodine is where the OH used to be. So we draw the molecule exactly the way it looked before, but the iodine is now an alcohol group.